As we begin studying functions, one thing that we're going to start using is function notation. So at the end of this video, you'll be able to evaluate a function using function notation. All right, first of all, I am going to say all of these problems, we have already done problems like this. They're just written a little bit differently, so that's what's going to make them different, but they're not going to be any harder, I promise. Okay, function notation looks like this. There's going to be an f, and then there's going to be parentheses, and then an x. The way that we are going to read that is f of x. And basically this is just saying that f is a function of x. X is going to be our independent variable. F will be our dependent variable. Okay, we are going to treat the f like a y. So that's going to basically be our y value when we get to graphing and doing things like that. Just a real quick note, why would I call something f of x instead of why don't I just call it y? When we start working with more than one function, we're going to want to distinguish between the two functions, and if they're both called y, it makes it hard to say which one am I talking about. So if I call one of them f of x, I could call another one of them g of x. That's a popular one. We might call it h of x. I can call it m of x. I can call it t of x. I can call it anything. That just helps me distinguish between different functions when I do that. So, and again, in my calculus class, you'll see me writing f of x quite a bit on the board when we work things because we use function notation all the time. All right, example, evaluate the function when x equals -4 and x equals 2. We actually have had warm-up similar to this lately. We just haven't had the f of x in there instead. So what we are going to do, it says evaluate this when x equals -4. So wherever we see an x, we're going to put a -4. So we're going to put f of -4 equals 2, and when we have an x right next to the 2, I generally like to put it in parentheses. And then it says -3. Okay, the left side, there's nothing to do with the left side, so we're just going to leave it alone. And now we're going to evaluate or simplify the right side. So 2 times -4 is -8, and then -8 minus 3 is -11. So we have just found that f of -4, when the x value is -4, our y value is -11. Okay, then it says also to evaluate it when x equals 2. So again, I'm going to come up here, and I'm going to plug 2 in for the x. So I'm going to put f of 2 equals 2 parentheses 2 minus 3. Okay, the left side we just leave alone. And then the right side, 2 times 2 is 4, 4 minus 3 is 1. So f of 2 equals 1, and again what that means, when x equals 2, my y value is 1. All right, next example, f of x equals 5x. So same thing again, we're letting x equals -4, so I'll put f of -4 equals, and then 5, since x is right next to the 5, I'll put it in parentheses, and we know x is -4. Left side we don't do anything with. And then the right side, 5 times -4 is -20. So when x is equal to -4, the function value is equal to -20. All right, let's try when x equals 2. So we'll have f of 2 equals, and then we'll plug the 2 in place of the x. So again, we'll just rewrite the f of 2, and then 5 times 2 is 10. So f of 2 is equal to 10. All right, what I'd like you to do on this one is please pause the video, try it on your own, and then come back and see if you did it right. Okay, so hopefully you're just back after you've tried it on your own. We are going to go ahead and plug in -4 wherever I see an x, so that's exactly what I'm doing right now. Again, since the 2 is right next to the x, we'll put it in parentheses. So here we go. Following my order, I'm going to put h of -4 equals, following my order of operations, I do need to do this first. -2 times -4 is a +8, so 7 plus 8 is 15. So h of -4 is 15. And then 2, h of 2 equals 7 minus 2 times 2. So I'll have h of 2 equals, again, we get to do the multiplication first, so 2 times 2 is 4, 7 minus 4 is 3. So there we go for that. All right, another example, let n of t, so notice we're just changing instead of f or x, we're just using different variables, that's okay, be the number of DVDs you have in your collection after t trips to the video store. Explain the meaning of each statement. So we just need to decide what does that mean in the context of the situation. Well, notice the t is in the parentheses, so it told you that t is the number of trips that you're taking to the video store. So in this example, this value is the t. So what does that mean? That means you have taken no trips to the video store. The 8 stands for the N value, so it tells you that the N value is the number of DVDs in your collection. So this pretty much means that before you've taken any trips to the video store, you have 8 DVDs in your collection. So I'm just going to write that down. Before you have taken any trips to the video store, you have 8 DVDs. Okay, now if we look at B, again, 3 stands for the T, so that means after 3 trips, and then the N stands for the number of DVDs, so we can now say after 3 trips to the video store, you now have 14 DVDs in your collection. So after 3 trips to the video store, you have 14 DVDs. All right, and then C, this one's a little different. It says N of 5 is greater than N of 3. So we know that 5 stands for the T, so does 3. So this first one means after 5 trips to the video store. This one means after 3 trips to the video store. And remember, N stands for the number of DVDs. So the way that I would read this, after 5 trips to the video store, I have more videos than I had after 3 trips, and I think that would make sense because the more you've gone to the video store, the more DVDs you're going to have. So I will just say after 5 trips to the video store, I have more DVDs than I did after 3 trips. And again, this is just getting you used to seeing it in notation and what do those things mean when we look at them instead of like a foreign language. Right, number 5, it says to find the value of x so that f of x is equal to 2. So we're looking for the x value, and remember it says look for this so that f of x is equal to 2. F of x is just another way of saying y. So find the x value so that the y value is 2. Well, we know the y is on this axis, and we know x is on the horizontal axis, so I'm going to look for a y value of 2. So I'm going to go up to y equals 2. And I'm just going to come over here. And then it says find the value of x. So what value of x is at that dot? It would be an x value of 3. So x equals 3 when f of x equals 2. All right, let's do one more example. Let f of x equals 300 minus 75x represent the number of miles a helicopter is from its destination after x hours. So just remember the x stands for the number of hours. All right, and it says how far is the helicopter after 2 hours? And if we look at this, this is just going to be our x because we know x is a number of hours. So wherever I see an x, I'm going to put a 2. So we're going to put f of 2 equals 300 minus 75 times 2. Right, and if I work that out, 75 times 2 is 150. 300 minus 150 is 150. So f of 2 equals 150, and answering the question, how far away is a helicopter? It's 150 miles away. All right, and then part B, that's part A. Part B says, how long does it take the helicopter to be 100 miles away? Well, we know if x is the number of hours, then f is going to be the number of miles. So what we're trying to do is figure out in this equation, 300 minus 75x, we're trying to figure out when this answer is going to be 100. And so we can just try to think about this, I guess. I noticed after 2 hours, I'm 150 miles away, so I'm going to try if I were 3 hours away. So if I do f of 3 equals, and I'm going to do 300 minus 75 times 3. 75 times 3 is 225. So 300 minus 225 is 75. So after 3 hours, I'm 75 miles away. I want to know how long does it take for the helicopter to be 100 miles away. It's going to be somewhere between there. So I'm going to put between 2 and 3 hours. And if you wanted to get pickier, you could try 2.5, you could try 2.6 until you got something that's pretty close to 100. All right, so hopefully now you are familiar with working with functions that are in function notation.